Hello everyone. Today I just received one of the challenging question from one of my students. So I would like to take this opportunity to share this question with all of you who are Form 5 students. I really hope that it can help you to understand the concept and you will gain confidence. Okay, let's have a look at the question. Hi, you won't be surprised. I use this way to explain to you. Okay, so I'm glad that you try a lot on your own and you send me the question. But I think I have to choose this way to explain to you. I'm sorry because actually this question involving concept. So and this concept actually I try to explain to many students and they actually take times to memorize, so they tend to forget easily. So I think I should make a video, so in case you forgot then you can refer back, right? So actually this is actually the best way for everyone to learn. I'm sure nowadays there are many ways to learn, so one of the best way to learn is actually through video teaching. Okay, so now so for the question that you just sent over to me, it sounds like quite interesting and the question actually quite challenging. So for me to explain to you through phone or through telegram is not, it's not good enough for me to make sure you really understand. So I think I try out this way, then you try, and if you really still cannot understand, then you can just text me and then I will try another way, maybe. Okay, so now you see the question that you asked is actually need you to revise back the concept in Form 4 for the topic of differentiation. You still remember dy dx, right? And that is actually connection with the Form 5 topic. So that means if your Form 4 topic you've forgotten, then the Form 5 topic is beginning of the year. Also you've forgotten, so it's hard for you to do this question. There's a connection between Form 4 and Form 5. So there's a bridge between them. So actually this question is testing you the concept of integration is actually reversing process of differentiation. You see the sentence also sound like very difficult to accept, right? But actually in fact it's quite easy if you follow the flow of steps. So now let me explain to you again, right? Okay, let's say if you have the y equal to x squared, right? If I ask you to differentiate, I'm sure you got no problem, isn't it? dy dx you can do, sure. So dy dx is 2x, right? Okay, so you just bring the 2, then x power 1. Okay, so I'm sure everyone got no problem with dy dx, unless you forgot the formula. So now, if I actually ask you to integrate 2x, what do you get? So when you integrate, isn't it you raise the power, take the power 1 plus 1, 2x 1 plus 1 over 2. So you get back the x squared, isn't it? So let's say your dy dx is 2x, alright. Now you integrate your dy dx, okay. When you integrate your dy dx, isn't it you get back your y? Right? So in short, that is a relationship between y, dy dx and then the integration and differentiation. So when you actually integrate your dy dx, you will get back your y. So this is a concept that you need to know. So it sounds like very simple, the sentence like integrate dy dx is y. But if you forgot this sentence, you actually cannot do the question that you ask, you see. So just memorize this. If you are actually given y, okay, like just now the question say you're given, actually the question never tell you is y. They purposely don't want to give you y. They say differentiate. So that means that is actually y, you see. Okay, when you differentiate, of course you differentiate y, isn't it? dy dx. Differentiate means d dx. So sometimes the terms make you all very confused, right? Okay, so when you see differentiate, of course the y is given. So the function is given. Function also means y. Okay, so actually the question give you y. Do you know that? So if I were you, I just dy dx only. Then after that, maybe you can get marks for the dy dx. Right, so you just assign y equal to the function given. Okay, so I'm explaining to you the integrate the dy dx, you will get y. So this is an important concept. So integration is actually reversing process of differentiation, meaning that if you uh, differentiate, okay, y, you differentiate, you got 2x. So when you integrate your dy dx, you will get y. That is the meaning. Reversing process. So you reverse back, you will get back your y. Okay, integrate your dy dx, you'll get back your y. So actually you don't have to do anything, you know. When they ask you to do integrate of dy dx, you just take the y as your answer and you just substitute the limit. That's all. You don't have to use any formula. Just use the concept, reverse back. That's all. Alright, so can understand the concept? Okay, can So y equal to x squared, dy dx equal to 2x. When you integrate your dy dx, you get your y. Okay, I'm telling you as dy dx is actually y. Y equal to fx also can be written as the function is actually the y. So when you dy dx, you can write as f prime x. So integrate dy dx, you get y. So this is the concept. You can jot down this one in your diary or stick on somewhere so that you can recall. Or you can write integrate f prime x equal to fx plus c, the same story. But they use a different symbol so that you are confused. Okay, so now let's see, you want to solve the question, right? The question that you, let's see the question that you sent to me. Before that, I think I have to explain to you the concept first before we go to the question. Okay, so just memorize this concept first. Integrate your dy dx, you get y plus c. Okay, integrate your f prime x, you get fx plus c. In short, integration is a reversing process of differentiation. Okay, can you accept this fact? This is called a statement. Okay, settle. Now, we're going to start with the question that you sent to me. So, by looking at the question that you sent to me, we will identify the y first before we start. Okay. So the y that written in your question is actually quite complicated, right? So later I will explain to you. Now I need to make sure you understand this one first. So I keep on writing this one. It's actually the third time. Okay, when you have the y, you dy dx. Okay, you get 2x. So when you integrate your 2x, you will get the y again. Alright, so this one is the basic concept that you must know. Alright, so let's see the question that you sent to me just now. So the question is saying that differentiate 3x squared minus 4 square root x over x with respect to x. You see, the moment I see they say differentiate, I will write down y. Y is given. So y is 3x squared minus 4 square root x over x. So the moment I see this one, I will find the dy dx first. Okay, so I will actually write y equal to the function given, and then I will differentiate. But in order to differentiate this one, maybe you feel a bit unusual because there is a fraction, right? Alright, so but my advice to you is we always try to simplify until we can see the number x and the power, okay, so that we can use a formula y equal to axn dy dx equal to nax n minus 1, remember? So that means you can't even differentiate when you have the fraction like this. So in this case, you will have to divide the x term by term, meaning that you will write like this 3x squared over x, okay? Then you minus 4 square root x over x. Okay, actually for additional max, like in indices, logarithm, integration, differentiation, we want to focus to the power. Okay, we want to see the power. Okay, we want to see the index. So we have to simplify until we can see a is a number, x, then x followed by we want to see the index, okay, the n. So we say we will simplify into axn. Then we will use a formula to differentiate. It become n a x n minus 1, right? When you differentiate any terms, example, you differentiate 2x power 3. So you bring down the 3, right? Okay, 3 and then times 2 times x. Then the power go down one step, alright? So a is actually 2, n is 3. So 3 times 2x, then 3 minus 1, 3x squared. Okay, if you are having terms like 2x power 3, so you write 3 times 2x power 2. So for differentiate, d always going down, like decrease, deteriorate, okay, descending. So you remember all the word d, the things will go down, so the power will go down one step. So I advise you don't use the u over v. That is actually wasting time, and then I think it will make the question become very tough and time consuming. So we just make it, the best way is before you do any differentiation, you try to ask yourself, can I express in axn or not? If can, then you don't use other alternative, okay? So you just use the shortest way to do. So you see, I will focus to the power, the 3x squared I divide by x minus 4x. When I see square root, I will convert to power half, alright? So I will write 4x power half over x. Then I will use the indices. I will simplify to the simplest form, 3x power 1. You see, I want to see the axn, and then 4x and 1 over 2. Because there is an x with the power 1, so you bring up will be minus 1, isn't it? Right. So 1 over 2 minus 1. So I insist I want to see the ax with the power. I don't want to see over x. Alright, understand? So you must see the ax and then power, then you can differentiate. Now I simplify further. I got 3x1, 4x negative half. Alright, so then I will do dy dx. Now it looks like you are having axn, right? So 1 times 3x 1 minus 1, which is 0. So normally for 3x we will get 3 because it's 3x. 1 times 3x power 0. X power 0 is 1, so it's 3. And then this one, be careful, you got negative 4, but you have to times to the negative half, you know. So it become positive, right? Then x minus 1 over 2 minus 1, be careful, this is minus. Differentiation, the differentiation go down. Okay, so your dy dx is 3 plus 2x, right? Become positive, right? Negative 4 and negative half become positive 2, right? X and then negative 3 over 2, right? Now you see, I want to highlight to you, you got a dy dx already, right? So you must make sure you simplify your dy dx to the, not only the simplest form, but to the form that given by the question. It must be almost the same. You get what I mean? So in the coming SPM exam, right? Let's say you see, you have to connect the dy dx and integration, right? So you always make sure your dy dx is actually something alike with the one given by the integration. You get what I mean? So I'm going to modify the dy dx so that it will be almost the same with the one given in the question. You see, the question is given you integrate 3x squared, right? plus 2 square root x over 2x squared, right? Can you see that? Okay, so when we integrate the dy dx, we get y. So I must make sure integrate the function, that function actually is a dy dx, you know. So I want to make sure my dy dx is almost almost alike, but not exactly the same with the one given in the question. So I have to modify something, okay? I have to do something. Either I simplify or I try to make it the same denominator. All right, so let's see how we do. So let me do comparison between the dy dx in the question and my dy dx. Okay, I look at the dy dx given, I do a comparison. So I notice that the denominator, okay, for the dy dx is, it seems I'm having the denominator which is not the same with mine. I'm having denominator x power 3 over 2. But the question is having the denominator 2x squared. So I don't bother about 2, but I just concerned about x squared. So I'm thinking how to convert my x power 3 over 2 into x squared. I can, right? I have to do so that it can be, I mean, I can do connection between the dy dx and the y. So if you have x power 3 over 2, so you need to modify until you can see the dy dx is almost alike with the one given by the question. Yeah, because when you integrate, of course you integrate the dy dx, isn't it? Okay, but we just forget about the number. We just focus on the denominator. So I'm having x 3 over 2. So the question is having x squared. So now in my mind, I'm thinking to times x 1 over 2. So x is x power 1 over 2. Alright, so let's see how I do. So I will times x, okay, for up and down, right? I want to make sure the denominator, I will get x squared. Okay, so I will time x 1 over 2, the power index 1 over 2, up and down. So the up one also you have to do the same. So if I time x 1 over 2 for the term x 3 over 2 plus 1 over 2 is x 4 over 2, which is x squared, isn't it? So I finally can get the same denominator, which is x squared, right? So now, okay, I focus on that one. I highlight to you the x squared. Okay, so I work on the denominator first. Then after that, I will do for the rest so that I can join them to become same denominator. It's okay with the over 2 because the over 2 is the number we can solve later on. So you see, I'm going to times with the x power 1 over 2 up and down. Okay, so that my dy dx will be almost the same. It won't be exactly the same because of the number. Alright, so I will make it almost the same, almost alike. Then I just modify later on. So I will times with the x up and down, x power 1 over 2. Alright, so I show you again, x power 1 over 2. And then up also I times with the x power 1 over 2. Alright, so you understand why I do so? Because I want to make it similar. Okay, looks like alike lah, huh? Okay, so your dy dx now will become almost alike. You got 3 plus 2x power half, right? And then the down one is x, this is x power half, and then the down one is x. 3 plus 1 is 4. 4 over 2 is actually x squared, isn't it? So finally, my denominator, I solve it. I got dy dx equal to 3 plus 2x power half is actually square root of x, right? Okay, so x squared, right? So still just one more step to make it the 99% the same with the one given in the question. Okay, so now I times the x squared for this term. Alright, then I can join them. So now my dy dx will be 3 x squared plus 2 square root x, right, over x squared it looks like almost alike. You can check and see, you can compare. It's just that there is a 2 down there, right, for the question one, but my one without the over 2, right? So actually good enough. We have modified until this stage. So with the number, we forget about number first. So we have modified the dy dx. So dy dx is nice, beautiful. Now if I ask you, if I integrate my dy dx, okay, what I will get? Can you answer me? Let's say I integrate back my dy dx. Alright, I already modified the dy dx so that it look alike with the one given in the question. Because later I want to integrate what? Okay, so if I integrate my dy dx, what I will get? So can you answer me? So if you can answer me, that means you will get the answer already. You don't have to do anything. Okay, so your answer is, if I integrate 3x squared plus 2 square root x over x squared, that is my dy dx, I will get the y, isn't it? But the question is asking you half of this, half of the my dy dx. So of course you will get half of the y, isn't it? You understand what I mean? So I already got the dy dx. If I integrate my dy dx, I just integrate. I will get the y back. The y just now the question gave you, the beginning, the question give you the function that is a y. You just actually take that y and substitute the limit will do. But because there is a over 2 for the question, right? There is over 2. So you have to divide by 2 for every term. So because the question is asking half of my dy dx, it's not the whole dy dx. You understand? If the question asking without the 2, then I will write the I will write the y, and then I will substitute the limit 1 to 9, then I will solve it. But because the question there got half, isn't it? Half, it's divided by 2. It's not 2 times, it's 1 over 2 times. So I will actually take the dy dx. Okay, I substitute the, I will integrate my dy dx. I will get back my y, and then I will substitute the limit 1 to 9, and then I have to divide by 2, or you can say you times half, the same story. Alright, understand? So this question actually tests you the concept lah. If you understand the concept, you will know how to work for it. Okay, so now I show you again. I want to integrate the dy dx obtained by me. This is my dy dx. It's not the one asking by the question. So if I integrate my dy dx, okay, I will get y plus c with respect to x, dx. So I can just copy down this y. That is a y, isn't it? So you can say integrate the dy dx. You will get this answer, which is a y, and you can copy down the y. Alright, and you just times half, because the question is having half, is having over 2 there. Clear? Okay, so both side you times half, because there is a over 2. Or you can say you find the y first, then later you take the y, you substitute the limit 1 to 9, then you divide by 2 also can, no problem. Okay, clear? Understand? Alright? Okay, right. So now I'm showing you we're having 1 over 2, because there is a over 2 there. It's not 2 times, it's half time. So because this is for integration we have a 2 type. One is definite integral, one is indefinite integral. So if you have plus c, that is called indefinite integral. Now because I got the limit 1 to 9, so it become without the c. You don't have to write the c, because the c actually will cancel out later on also. So you just substitute 1 to 9. This is called definite integral. So for sure, definitely you'll get an answer in number later on. Okay, so you can substitute the y. Beginning of the question they give you the y, but they don't want to tell you that is a y. Alright, so many students wonder how to do, because the y it was not given, isn't it? Okay, so you integrate your dy dx. Now the half actually I can multiply it with the 2, become 2x squared. So exactly this is what the question asks, isn't it? With the 2x squared. So now I have to times 1 over 2 there. Then only I copy down the y. Alright, the y given just now, given by the question. At the beginning of the question, that is a y given. So you can actually copy down carefully, then you substitute the limit carefully. I'm sure you will get the answer. Okay, let's copy down the y. Alright, can see. Okay, that's the y, beginning of the question. 3x squared minus 4 square root of x over x, right? Okay, that's the x. Huh? Okay, so you copy down the y and then you substitute the limit. Okay, then you simplify. So I'm copying the y again for you is 3x squared minus 4 square root of x over x, right? Okay, now let's copy down carefully and then we will substitute the limit carefully. So you have 3x squared minus 4 square root x over x, right? Alright, don't change the y. Okay, so the limit is from 1 to 9. So when you substitute, you must substitute the upper limit first and then minus the lower limit. And be careful for integration because you need to minus upper limit minus the lower limit. So you need to do it carefully. If possible, you try to use a bracket so that you won't make mistake. Alright, so we have 1 over 2, 3 times 9. We substitute the upper limit first. 9 square minus 4 square root 9 is just a nice number. You will get 3 after this. Over 9, isn't it? Is the x, you substitute with a 9. And minus, don't forget, you have to minus the lower limit, right? So when you minus, you must put bracket, because you have two terms. So many of the students tend to forget to put bracket. So you will get everything in a mess after this if you never put bracket. So always remember when you minusing more than two terms, alright, you have to put bracket. Okay, so you close the bracket and maybe you can try to use a calculator to solve, but I think I don't like to use calculator. So it's over 1, right? X is 1. Okay, now let's see what is the answer. If I solve it manually, I will get 1 over 2 times, inside the bracket, 3 times 81. Okay, then minus 4 times 3. Okay, so this is actually integration of the 3x squared plus 2 square root x over 2x squared, exactly asking by the question. That is why we have the half multiplied by the bracket there, right? Okay, so now we will simplify carefully so that we'll get the answer. So 1 over 2, 3 times 9 times 9, 81 minus 12, right? Over 9 minus 3 minus 4, okay? So you have negative 1, right? So you need to be very careful. When you minus a negative 1, you'll be plus 1 later on. So now you simplify carefully. I'm sure you will get the answer. Okay, so just remember when you solve, you need to be very, very careful, especially for integration, because it actually involves minus, right? So when you careful, then you will get the answer without mistake. So actually this is 77 over 3 plus 1. So we have 80 over 3, right? Alright, so 80 divided by 2, we get 40 over 3, right? And then if you want to write answer in mixed fraction will do, you can do so. Or you can actually, okay, so till then I think, right, I